So kind of a pointed question. Sorry about that. It's because I'm in the vermifiltration industry. It's a small world. I'm actually part of the company Perka, that's the direct competitor to the company you work for, Biofiltro. So I'm going to have a few different answers than Gilbert may have had, just because our technology is different, and because of a lot of the work I do in the Vermitech Innovation Center, which is the research and development portion of Perka. So my name is Sierra Smith. I'm the director of R&D for Perka, and today I'll be talking about the use of orchard debris for vermifiltration in order to advance regenerative agriculture and wastewater treatment. So Washington State is a global leader in apple production with more than 175,000 acres of orchards in the state. This produces over 68% of all apples produced in the United States. That's equivalent to 187 million 40-pound boxes of apples annually. A common management practice for orchards is to prune or tear out trees as needed. Tear outs, which is the largest contributor to debris waste, can be due to a change in market demand or due to replace old trees or low producing trees. So one of the big issues is that pruning and orchard tear out produces thousands of tons of debris annually with minimal ability to deal with the debris in an effective and sustainable manner. One of the most common management practices is open air burning of these orchard debris piles. This poses serious air quality effects and human impact. So like I said, orchard burning is one of the most common management practices for these tear out piles. And the most recent emission inventory produced by the Washington State Department of Ecology found this quantity of emissions in pounds per ton of material consumed. So there's a substantial amount of emissions produced in these open air burnings that happen all over Washington State. So in collaboration with the Washington State Department of Ecology and Washington State University, we decided to design a study to look at the utilization or create a value-added alternative for this orchard debris by utilizing it in a vermifiltration system as a substrate. So vermifiltration, which we've kind of talked about a little bit here, is the utilization of earthworms and associated biota in an organic matter base in order to treat contaminated wastewater. We specifically use Eisenia fetida and Eisenia andrei, which are a specific type of compost worm in these vermifiltration systems to treat and remove and sequester and transform these toxic and standard wastewater contaminants within wastewater. There we go. So how this works actually is, and so just to go a little bit further into what vermifiltration is, water is collected from a source. In this case, it's an industrial application. It's collected, transported to a bed where it may or may not be pH adjusted before it's applied to the surface of a bed, percolating through what we call the drillosphere. The drillosphere is the area where these earthworms and microbes exist, and that is where the treatment of the wastewater occurs. So as water percolates through the system, it then goes into drainage where it goes to discharge, effectively treating toxic and standard contaminants in wastewater. The current market projection for Perka in the vermifiltration industry is 113% of a compound annual growth rate, leaving a wide market for the integration of something like orchard debris as a vermifiltration substrate. So in order to determine if applewood would work in a vermifiltration system, we first had to take the substrate and compare it against the current standard, which is a conifer wood species. So we obtained debris from an orchard, we screened, cold, chipped, and acquired adequate substrate that we can utilize in a bench scale vermifiltration test. So over here, you can see this apparatus on the right. This is called a rapid assay vermifiltration system, which is a bench scale vermifiltration system. So that picture you saw here, this full scale system, is essentially this on a laboratory scale level. So we call this a RAV column, and in one column we have applewood to test and compare against this other column over here where we have the control. We ran a test on both of these media substrates in order to determine if applewood was an effective media in treating real-life wastewater. We looked at two specific wastewater contaminants, total suspended solids and biological oxygen demand, as well as one toxic chemical, polychlorinated biphenyls. And the results were really promising. So over here, you see on the left-hand side, total suspended solids, in the middle, biological oxygen demand, and on the right, polychlorinated biphenyls. And these orange bars are the rate of reduction in a RAV column that you just saw that had applewood, and the green is the rate of reduction of contaminant in a RAV column with conifer wood. So you can see we had over 90% reduction in total suspended solids, With both media, over 80% of total BOD reduction with both media, and more than 84% reduction in polychlorinated biphenyls with both media. Statistically, we found that applewood was a significant reducting media for these contaminants, but there was no significant difference between the conifer wood and the applewood. This indicates to us that not only is applewood an effective media in a vermifiltration system, but it's not significantly different than our current media, meaning it is an effective drop-in replacement substrate for a vermifiltration system. So we know it works functionally, but in order for this to work on a realistic scale, it has to be applied economically. And so one of the things we looked at while we were going through the study was the cost and labor and time requirements in creating a suitable vermifiltration media from the wasted apple orchard debris. Here at the bottom, you see the results. We ended up calculating the cost per cubic yard of apple orchard debris substrate from a trellised orchard to be $1,719.10 per cubic yard, and from wood from a non-trellised orchard is $129.13. Compared to the current standard, which is conifer wood at $37.50 a cubic yard, it's not financially feasible. But I'd like to draw your attention to two things and talk about why it might not be this way for long. The first is this top row, the cost to separate trellis wire and foreign material and pile that material in cost per acre. You can see here that trellised orchards are about 5 times higher in cost than non-trellised orchards. For anyone unfamiliar, a trellised orchard uses wire and foreign debris to help support orchard trees in an orchard. And over time, that debris gets embedded into the wood. As you can see on this picture right here, you can see that's wire. In order to chip the wood to become usable material for a vermifiltration system or any other type of, chipped material, you have to manually remove all of this debris, which is extremely time-consuming, labor-intensive, and cost inefficient. Second line I'd like to draw attention to is this usable tons of wood per acre. You can see it's 4.25 tons in trellised orchards and 15.75 tons in non-trellised orchards. Another drawback of a trellised orchard is that due to the fact that these trees are using these wires for support, the trees are naturally smaller and thinner. In order to create optimal media for a vermifiltration system, there has to be an appropriate xylem to bark ratio for structural integrity of the media in a vermifiltration system. So with the cost and labor in separating and chipping all of the debris from these orchards, it is more cost inhibitory compared to the current model. But we're hoping, and there is promise, because we're looking at the potential for future technology to help lower the cost and lower these thresholds to remove debris and to screen and chip this wood for a value-added end product such as vermifiltration media. Technology is constantly evolving, it's rapid, and so we're hoping that in the next couple of years, this cost will come down dramatically. So back to the original question, how does the utilization of orchard debris material, how does it impact air quality? We ran some projections based on the Department of Ecology's emissions data, as well as our projected beds and volumes of wood needed in new systems, as well as replacing old systems. And we were able to project in increasing fashion more than 545 tons of emissions diverted by utilizing orchard debris into a value-added end product rather than open air burning. So overall implications is the utilization of orchard debris waste into a vermifiltration substrate is an effective way of utilizing creating a more value-added product for orchard debris rather than open air burning. The utilization of this waste as a substrate reduces air pollution and is a prime example of industrial symbiosis, which is the utilization of a waste product from another industry as a raw material or input into a new industry. Additionally, other outputs from vermifiltration systems, such as clean water and compost, can be used for irrigation water and for fertilization, which is not only sustainable, but also supports this concept of circular bioeconomy, of perpetually using inputs from a different industry or waste from one industry as inputs to another industry, and then continuing that process down the line. And so overall, this case study is a good example of how agricultural and industrial partnerships can not only increase environmental sustainability, but also economic resilience. Thank you all for coming. Any questions?